Okay, problem number 8. A ball is dropped from a height of 10 meters. Let's draw a little diagram here. Here's some ball. It's being dropped from that initial height of 10 meters. Each time the ball bounces, it rebounds. You can't read that. It rebounds 7/10 the distance that it drops. What's the total distance the ball travels? So think about what that means. If it rebounds 7/10 the distance it drops, it means on the second height, it's going to go from that height of 10, it's only going to go 7/10 of that height, which is 7. So my second term then is going to be 7. So let's say here's my ground. Here's the ball. Think about what it's going to do. It's going to go down. It's going to bounce back up to a new height of 7. Now, that would be I'm going to call that my first term, because I'm going to let my terms be the height after the bounce. A sub n is the height after bounce n. That is going to be important here. I'm calling 7 my first term, not 10, 7. So then what would my next height be, just to do one more just for fun? Well, then I would take my 7 and multiply it by 7/10, which means I would get 49/10, which is 4.9 meters. So then my next height is going to be down here at 4.9. So again, from the first drop, it went down once and bounced up to the 7, but then it's going to bounce back down 7 meters and then up to the 4.9, and then down and up and down and up and down and up and down and up and down and up. But the key is, for each actual term in my sequence, first term, second term, nth term, each term is actually traveling double the term value because it's going up and down. And so if we want to do this as a series, we're going to start with our first term. We're going to do it as an infinite series because that will simulate the ball bouncing infinitely many times, aka until that bounce height goes to 0 and it's no longer bouncing. So I know this seems weird to some of you because you're like, well, it's not going to bounce infinitely many times. No, it's not, but mathematically this is how we can simulate this experience. But what is my sequence then? What's the generator here? Well, it's going to be the first term, 7, times my common ratio, which is 7/10 raised to the power of n minus 1, just like that. Now, this alone is not going to be the total distance it travels. We need to take double this sum to give us the distance it travels from the bouncing, but then we also have that original 10, so I need to add 10 to that. So, let's simplify this. 10 plus 2 times, now we need to find this infinite sum right there, which we can because it is geometric and r is between 1 and -1. So what is my formula? Well, my formula is the infinite sum equals first term divided by 1 minus my ratio. Well, my first term is 7 divided by 1 minus my ratio is 7/10. So let's continue to simplify this. 10 plus 2 times 7 over 1 minus 7/10 is 3/10 right there. I can continue to simplify this. 10 plus 2 times 7 over 3/10 is the same as 7 times 10/3. And at this point, I'm going to pull a calculator out, and I'm going to crunch those numbers. I'm going to get 56.6 repeating. And again, our units are meters, and that is how far this ball traveled.